Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.
As we have shown in my previous mathematical lesson, I have said that there are some types of sets which are most often referred when we are dealing with mathematical problems. May I remind you that I'm taking you through factors, prime numbers, composite numbers, even numbers, odd numbers, and multiples in our previous lessons. And as you realize, I took you through some practical activities before the finishings of these numbers of sets were given. In our last lessons, I have also taken you through types of sets. I started with finite. I went to infinite. I went to null set. I went to a unit set. I went to union set. Then to universal set. Then finally, I came to a subset. And that is where I ended. And so if you had not watched my previous tutorials, you can go to AGPS TV, then you hit the subscription button, then on the top you see home, you see videos, you see playlists, but you touch on the videos, then you see mathematical lesson on sets. Then you can watch these mathematical problems, and after that you can enjoy yourself on my previous tutorials. You can also engage yourself with me on Friday for another tutorials. My name is Mr. Samson Anane, and today we are going to deal with, as I promised, the continuation of the types of sets. And then if you remember, under types of sets, I had read subset. I have read subset in my previous lessons. And under subset, I have talked about the universal set U. And the universal set U, I assume that let us look at members of the universal set as 1 to 10. So if these are the members of the universal set, and then A is a subset of the universal set, as the members are 1, 2, 3, and 4, I have said that you can call A as a subset of the universal set, because all the members in set A are also members of set, the universal set. They are also members of the universal set. So the last time, by definition, I said that set A is said to be a subset of set U if all the members of set A are also members of set U. So that is where we ended. And then I added that for set A, we can tell you to list the number of subsets. And before you can list the number of subsets, you should be able to know how many number of subsets you can list. Before you be able to list all of them, you should be able to know how to list it. So if you remember, I had given set A to be A, B, C, and D. And then when I have given you that set, I have said that you can know the number of subsets you can form from set A, which is given by 2 to the power n. 2 to the power n, where n is the number of elements in set A. So if you count the number of elements in set A, we have 1, 2, 3, 4. So we conclude that our n is 4. So the last time, if you remember, if our n is 4, then we can simply write our 2 raised to the power 4. And then 2 raised to the power 4 can be written as 2 by 2 by 2 by 2. And so we said we have 2 times 2 times 2 times 2. And so 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So if you know this, if you're asked to list, then you should know that you have to list 16 different subsets from set A, which is A, B, C, and D. But before we go into the 16, let us look at a set with 3 members. So if I have set B, which is A, B, and C as its members, and we want to list all possible subsets that we can form from set B, all possible subsets that we can form from set B, then what we need to do is to first of all try to find the number of subsets we can form. You should know how many subsets you can form. And for you to be able to know how many subsets you can form, we are saying that it is given by, as I've just done, 2 raised to the power n, where n again is your number of members. So here we can conclude that our n is equals to 3, as we have in 1, 2, 3. Now, we will now write our 2 raised to the power 3. And that 2 raised to the power 3 then gives us 2 by 2 by 2. And 2 times 2 is 4, and 4 times 2 is 8. Therefore, we write our answer 8. It means that for set B, with members as A, B, and C, we can form 8 different sets which are going to be subset of set P. And that brings us to today's topic. How are you going to form these subsets? Now, let us try to see if we will be able to form 8 subsets. So the first thing you must do is that you are going to pick the individual members as individual sets. So I am going to pick the individual member A as my first set. Then I will again pick my B as my second set. Then I'll pick again C as my next set. Don't forget that when all the members of a set belongs to another set, then we can say that they are subset of that given set. So because A can be found, B can be found, and C can be found, we say that A, B, C are subset of B. So when you are asked to list the number of subsets, pick the individual elements as individual sets. That is the first thing that you must do. The second thing is that try to pick the A and try to combine A with other members. Try to combine A with other members. So if I pick my A, I can pick my A and combine it with set B. So I have AB as a subset of B. So I'm combining the individual members. So now that I've picked my AB, I can also pick my A and then my C. So I'm combining the members together. So I have my A and then C. So if I pick A, I will look at all possible combinations that I can do. But don't forget, you cannot interchange them as different members. For example, if you have AB, you cannot also write BA as a different subset. If you have AB, you cannot write BA as a different subset. And if you have AC, you cannot also write CA as a different subset, because AB and BA are equal sets, as I showed in my previous lesson. Now, I can also pick A, B, C. I have picked AB, I have picked AC, I can also pick A, B, C. So I can pick my AB, my AC, and I can pick my A, B, and C. So if I pick my A, B, C, then I have that combination. Now I am done with A. These are all the possible combinations I can do for A. So the advice is that if you pick one member, try to look at every possible combination that you can do. So in this case, I have my A and then B, my A and then C, and then my A, B, and C. Now, I go to the next one, which is B. So for B, I can also pick my BC. Don't forget, I cannot pick BA because I've already taken my AB. So for B, I can only pick B and then C. Now, if you count it, you have 1, 2, 3, 4, 5, 6, and 7. So you realize that I have 7 subsets, as it has been shown. But from the calculations that we have done, we are saying that we can form 8 different subsets. Why are we left with 7, even though we have done all possible combinations? That is because we have left one subset out. You will have to understand that an empty set is a subset of all sets. So when you take any set and you want its subsets, then you can take an empty set or a null set as a subset of that given set. So we are going to add an empty set to it. And so when we add that empty set to the 7 previous sets we have done, then that brings us to 8 different subsets from set B. And so from here we have A, B, C, AB, AC, ABC, BC, and then we have the empty set. So anytime we are asked to list a number of subsets, if you don't know, an empty set is a subset of any set. Now, I have shown you another set A, which has 4 members. So let me change the name of the set to set A, and let me include D, like I just gave. Now for D, we are going to have 16 sets. And as I've shown you, it is 2 raised to the power n. And our n is 4. And 2 raised to the power 4 is 16. I have just done the calculation. So we have to get 16 subsets from this set. And as I have done, I know by the time I am through, you'll be able to understand it fully if my first explanation had not gone down well with you. It is my belief that after 16, you should be able to do that. After that, I am going to increase it to E, and that will give you 32, and that is your assignment. You should be able to do all the 32 combinations. And then if you're able to do 32, you'll be able to do any further combinations. So I have said that for you to form 16 subsets, first of all, you must have all possible combinations. I'll pick the individual set. So for now, the individual set, we are going to have A as first individual set, then B, C, and then D. So this only gives you about 4 subsets. So like I have said in the first example, pick the individual members as individual sets. And now when you have done, I am going to pick my A and do all possible combinations. All possible combinations with my A. I'll pick my B, do all possible combinations with my B, pick my C, and then my D in that order. So for my A, I can pick AB, like I did with the 8. Then I can also pick my AC. Then I can pick my AD. So I have AB, AC, and AD. Not only that, I can also pick my A, C, and B. So I have my A, B, C. A, B, C. Not only that, I can also pick A, C, D. A, C, D. It's another combination that I can do. A, C, D. Aside A, C, D, I can also pick A, B, and D. So I have my A, B, C, A, C, D, and A, B, D. All these are possible combinations that I can form with my A. And all of these sets are going to be subsets of the set A. Is that the only combination I can do for A? No. I can also pick my A, B, C, D as a possible combination. So I pick my A, B, C, and D. So all these are the possible combinations that I can do for A. I have my AB, I have my AC, I have my AD, I have my ABC, I have my ABD, and I have my ACD, as well as my ABCD. All these are combinations that I can do. Now that I'm done with my possible combinations of A, I then go to my B. And for my B, I can pick my BC, and I can also pick my BD. So I pick my BC and my BD. So these are also a good combination. Apart from my BC and my BD, I can also pick my BCD. BCD. It is also a possible combination for B. So I pick my B, C, and then D. Now, I have done my A, I have done my B, so I come to C. And for C, I can also have my combination as CD. Don't forget, you cannot interchange any of the sets as a possible one. Now, let me try and add my empty set. Empty set. So when I add my empty set, let me try and count my set. The subset I have formed from set A, and see if I have 16. So I have mine 1, 2, 3, 4, then we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then including the empty set, I have 16. So this is how you are going to form or list the subset if you're asked to do it. And so it is not difficult. You have to try them and practice it, then you are going to get it. The assignment is that I want you to go and then list the number of subsets for set A. So I want you to list the number of subsets we can form from set A with A, B, C, D, and E. I am expecting you to get 32 subsets. And then in the next meeting, during our next meeting on Friday, if you are challenged, please just type your challenge on the comment section, and I'm going to help you with it. And I hope you have found how to list the subset very helpful. Our next subtopic I want to deal with is a complement of a set. A complement of a set. A complement of a set. Now, let us take U as our universal set. I told you once again, if you don't know anything on universal set, go to YouTube, LGPS TV as you're on right now. Just look on my tutorials on Monday, and then you have talked about universal set as all the set under correction, and it's the bigger set or the mother set. So you go to that video and then you get the understanding better. So let us take our U. As members, having members 1 to 10. Then let us look at another set A. And let's say that set A is a subset of the universal set. Once again, I have dealt with subset. I told you that these things are very important, and then we will continue to refer to them. In exams, we will continue to refer to them. So if you don't have this concept, please go back and watch the video. But for the purposes of today's lessons, I am going to repeat it. Complement of a set. Now, when we say a complement of a set, I want to take you through activities. So let's say that A is a subset of the universal set, such that A are odd numbers. Set A are odd numbers. So we are going to pick all the odd numbers from the universal set, since this is a subset of it. Odd numbers. So these are the possible members that are odd that can be found in the universal set. Now, for a complement, we simply write A with a small inscription at the top. A with a small inscription at the top. So we have A complement. Now, for a complement of a set, we are saying that let us look at all the members that are in the universal set, but not in set A. All the members in the universal set, but they are not in set A. And all the members in the universal set that are not in set A are going to be A complement. All the members in the universal set that cannot be found in set A will be called A complement. So what members are in the universal set, but they are not in set A? And so we are going to have 2 is in the universal set, but not in set A. Therefore, it becomes A complement. We have 4, 6, 8, and 10. So all the members that are in the universal set, but not in set A, are called A complement, or they are complement of set A. So what are complement of a set? Complement of a set are all the members that are found in the universal set, but not in a particular set. All the members that are found in the universal set, but not in a particular set, are said to be complement of that set. Once again, if you pick set B as a subset of the universal set, such that they are prime numbers, and for us to write prime numbers from U, we are going to have 2, 3, 5, and then 7. So these are the set of prime numbers in the universal set, if we consider B to be a subset of set U. And so when you want to find B complement, all that we want to say is that look for all members that are in the universal set, but they are not in set B as a B complement. So once again, I'm going to write members that are in the universal set but cannot be found in set B as my B complement. And so we are going to have 1, 4, 6, 8, 9, and 10. Why is it that 1, 4, 6, 8, 9, and 10 considered to be B complement? They are B complement because they can be found in the universal set U, but not in set B. That makes them B complement. I hope you have found these 2 examples helpful. Now, I want to maintain my universal set U. Then we want to add some questions. So let's again take our A as 2, 4, 6, and our B to be 2, 3, 5, and then 7. Then you are asked to find A complement union B complement. You are asked to find A complement union B complement. In my last lesson, I told you that union simply means put two or more sets together without repeating any member twice. So for you to answer A complement union B complement, it's important to first of all find your A complement as a set, then find B complement as another set, and after that you can put them together. So let us first look at A complement. So for A complement, we are looking for members in the universal set, but not in set A. We are looking for members in the universal set, but not in set A. So we have our A complement to be 1, so we have 1, 3, 5, 7, 8, 9, and 10 as A complement. It means that these are members that are in the universal set, but they are not in set A. Then we again find our B complement. And so in our B complement, we are also going to look for members in the universal set, but not in set B. So we are going to have again 1, 4, then we are going to have our 6, our 8, our 9, and then 10. So now we have 2 sets. We have A complement, and then we have B complement. And these are the members. After you have found your A complement and then your B complement, you can now find your A complement union B complement. And so if you want to find your A complement union B complement, it means that put set A or A complement and B complement together. It means put A complement and B complement together. And so if you want to put your A complement and B complement together, then this is what you are going to have. A complement, and then you are going to have this. So we have 1, 3, 4, 6, 7. I told you that we are not repeating any number twice. So we have 8, 9, and then 10. So first of all, for our A complement, we have to find it. We find our B complement. Then for us to find our A complement, B complement, you put the A complement and the B complement together. So this is how we find it. Then another way, you can ask to find another one. And to find another one, they can ask you to find A union B all complement. A union B all complement. This is a little bit different from what we have just done. The approach is not the same as A complement union B complement. So let's take two sets as set A. We have 2, 4, and 6. And set B, I have 2, 3, 5, 7. And then you're asked to find A union B, all complement. This is read as A union B, all complement. And for you to do that, I know your mathematics teacher has told you that in every mass, we do the ones in the bracket first. And what is in the bracket is A union B. I told you this is different. The first one, we found A complement, B complement, then we put them together. But this time around, because we are dealing in the one in the bracket first, we are going to find our A union B. That is the one in the bracket first. And so we find our A union B. And so our A union B means that we should put set A and set B together. And by putting it together, we are going to have our 2, 3, 4, 5, 6, and then 7. So for our A union B, if we put A and set B together, we are having members as 2, 3, 4, 5, 6, and 7. After this, we can now find our A union B all complement. A union B all complement. Now, for A union B all complement, we are looking for members that are in the universal set, but they are not in A union B. For A union B all complement, we are looking for members that are in the universal set, but not in A union B. So you see that this approach is a little bit different from what you've done. It is different from the A complement, union B complement. This time around, we are going to look for members that are in the universal set, but not in set A union B. So what are the members in the universal set, but not in A union B? We can have our 1, then we can have our 8, our 9, and 10. And so you realize that now these are the members in the universal set, but not in A union B. So that becomes your A union B all complement. A union B all complement. And so I know once again this has been very helpful. And you'll be able to differentiate between A complement, union B complement, and then A union B all complement. I hope you are finding it very interesting. If you have any question or things you don't understand, please send your question through the comments section or column. I'll read it and I'm going to treat them with you. The next thing that I'm going to talk about is intersection of sets. Intersection of sets. When we have two sets, A, and then we have 2, 3, 5, 7, and then let's only maintain it as the first, say, 4 prime numbers. And then I've said B as my set of odd numbers less than 10. My set of odd numbers less than 10. I have 1, 3, 5, 7, and 9. The set of odd numbers less than 10. So I have 1, 3, 5, 7, 9. And so I want to find A intersection B. And this that you see is a symbol for intersection. It is not N. I may not be a perfect in terms of doing the symbol, but let us take it to be an intercession, but don't see it as N. It is just a symbol to show intercession. What does intercession mean? Consider set A and consider set B. You realize that there are some members in set A and the same members can be found in set B. If you can identify it, you see that you have some members in set A and then the same members can be found in set B. Can you identify them? Yes. I can see 3 is there, 3 is here. And so 3 is a corporate in terms of appearing in both sets. Then I can also see 5 and 5. So that it's also there. Then I can also see 7 and then 7. So we see that 3, 5, and 7 are members that can be found in both set A and set B. Therefore, we say that 3, 5, and 7 is an intersection of A and B. So A and intersection B, we have set to be members to be 3, 5, 7. So when we talk about intersection, we are saying that when members belongs to 2 or more sets, they are considered to be intersection of those sets. When we have members belonging to 2 or more sets, then we have an intersection of a set. Now let us also consider set C. We consider these 2 sets. Set C to be 2, 4, and 5. And set D to be 2, 4, 6, and 8 as its members. Can we write C intersection D? In other words, are there members that can be found in C at the same time in D? And the answer is yes, because we can talk about 2 and then 4 as members belonging to both sets. So C intersection D, we are going to have 2 and then 4. So that is for intersection. And finally, let us consider set A. So we have set A to be 1, 3, 5 as its members. And then we have set B to be 2, 4, 6. Now, when we are asked to find A intersection B, they are asking you to find members that can be found in set A and at the same time in set B. So you discover that A and B has no common member. Therefore, we say A intersection B is an empty set or a null set. Once again, I have talked about empty sets and a null set in our previous lesson. It is a set with no member. And so sometimes you see they ask you to find intersection of a set, and then it is going to be a null. When you come across such a set, don't be perturbed as if you've gotten it wrong. You are not, because some intersection of set can be null or an empty set. Now that you've done all this, we will go into the diagrams on how to represent subsets, how to represent union set and other sets. Now, the next type of set that I want to talk about is a disjoint set. A disjoint set. A disjoint set. A disjoint set. Another type of set that I want to talk about is a disjoint set. So once again, let me take you through some activities and say we have set A. Now, let's consider set A as 2, 4, 6, 8, and 10. And then set B has 1, 3, 5, 7, 9. You will discover that if you consider these two sets, it has no common member at all. In a previous lesson, you see that there were some members that were in set A and at the same time in set B. And we have described them to be union set. Sorry, we have described them to be intersection. We have described them to be intersection. But if you look at set A and set B, you will discover that it has no common member at all. And so we cannot find any intersection there. And so we are saying that any two or more sets without a common member, those two or more sets are called a disjoint set. They are disjoint because they don't have a common member. So two or more sets without a common member are said to be disjoint. And as it has been seen in set A and set B, they have no common member at all. Number 2, if you have set C, and then we have 10, 12, and then 14. And then we have set D, and then we have 16, 18, and 20. So these are the two sets. 10, 12, 14 are set members of set C. And members of set D, we have 16, we have 18, and 20. You again realize that set C and set D once again has no common member. And so we consider set C and set D to be a disjoint set. So that is where I am going to end as far as the type of sets are concerned. Another one that I'm going to help you with is the set builder notation. The set builder notation. If you want to list a member of a given set, we have 3 types. Number 1, so these are the 3 ways they can ask you to write sets or list the members of sets. So we have the listing, we have the word description, then we have the set builder notation. And for the word description, that's where I talked about the set of numbers. They can ask you to list odd numbers, even numbers, composite numbers, prime numbers, factors. So, for example, they can ask you to write set A. They tell you that S is such that S is a multiple of 3 less than 20. S is such that S is a multiple of 3 less than 20. So this is what we call word description. And so they can describe and they will ask you to list the members for set A. And once again, the last time I took you through multiples. And I knew this day will come where you'll be asked to list the members by description. And so I have taken you through for you to understand them so that you not find yourself wanting. But today what I want to place much emphasis on is the set builder notation. The set builder notation. Now, under set builder notation, we are going to use the less than, the greater than, the less than or equal to, or the greater than or equal to. These are the four symbols we are going to use for set builder notation. So for set builder notation, we are going to use these symbols. This is a less than symbol. This is a greater than symbol. This is less than or equal to, and greater than or equal to. So these are the symbols we use in set builder notation. And so when we say less than simply means smaller than. So if I write this, you can read it as S is less than 5. S is less than 5. S is less than 5. Now, in math, when we use a letter, it means that it is an unknown value. There are certain values of numbers we are not having information to, and then they're asking you to look for it. But the information they've given you is that any number that is less than 5 is X. Any number which is less than 5 is X. So what numbers are less than 5? You can talk about 4. You can talk about 3. You can talk about 2. You can talk about 1. You can talk about 0. We can even go into negatives. And all these things will be for X. Once again, we can also talk about S being greater than 3. S being greater than 3. So if our S is greater than 3, they are asking you to write numbers which are bigger than 3 as your S. So from here, if I tell you which numbers are bigger than 3, you will again mention 4, 5, 6, 7, 8, and so on and so forth. But you realize that anytime I use any of this builder notation, the set will be infinite. In other words, the last member cannot be found. As we have demonstrated in S less than 5 and S greater than 3. You write the members in such that you will not finish. And so we try to give a range so that the set will always be finite. So for set builder notation, the set is always finite. Now, so this is how we write set builder notation. So we have set A. Then we say S is like that. So when you are reading, you are going to read from the middle. S is like that. S is greater than -2, but less than 5. This is what we call set builder notation. That is going to give you a range. We are saying that S is a number says that that number is bigger than negative 2, but that number is less than 5. So they're asking you to write all numbers that you think are bigger than negative 2, but that number is smaller than 5. So if you want numbers that are bigger than negative 2, then you can talk about negative 1. You can talk about 0, 1, 2, 3, and 4 as a set A. So you discover that all these numbers are bigger than negative 2, but they are less than 5. Again, I can talk about set B. Then I say S is saying that 0 is less than S, but S is less than 10. In other words, I'm saying that S is a value, saying that that value is bigger than 0, but it is smaller than 10. So which numbers are bigger than 0, but it is less than 10? Those numbers are going to be your set B. So I have my B to be 1, because 1 is bigger than 0. Then 2, 3, 4, 5, 6, 7, 8, and 9. So these are numbers that are bigger than 0, but less than 10. Now, these are less and greater than. I'm using less and greater than. I am now going to use the less than or equal to and greater than or equal to. But I'm going to use it together with the less or greater than and then that combination. So let's stick by this set A, and let me put the equal sign under it. So you are going to read it as less or equal to. Now, when we say S is greater or equal to, it means that this negative 2 is inclusive. It means that this negative 2 is inclusive. So this means that you should always include negative 2 because it is either greater than negative 2 or equal. So we are going to have our A to be negative 2. That is the equal to before we come to the less. So we have 1, 0, 1, 2, 3, 4. Once again, you discover that it is less than 5. Now let me also put equal sign here. So now it reads S is greater or equal to negative 2 or less or equal to negative 5. Anytime you see less or equal to, it means that those numbers are inclusive. Therefore, our A becomes negative 2, negative 1, 0, 1, 2, 3, 4, and then 5. So that becomes your S is greater or equal to negative 2 or greater or equal to 5. So let me finally try if we can list these members. C, our S is said that our S is said that S is greater or equal to negative 4 or less or equal to 10. So the numbers, because these are less or equal to, it means that the negative 4 and the 10 are inclusive. Therefore, our set C becomes negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So this becomes our set C. That is from -4 to -10. This is where we are going to end today. I hope you have found this once again very helpful. Please watch my previous videos because I am building you somewhere. God willing, Friday, I am going to end with sets. And so we'll be dealing with properties of sets. I'll be dealing with the commutative property. I'm going to deal with the associative property. And I'm going to deal with the distributive property. Then I am going to take you through 2 set problems. I'm going to take you through 2 set problems. And under 2 set problems, I'm going to take you through 4 different types. 4 different types. Please make a date with me, so that anytime that you read a question under 2 set problem, when you read a question, I'll help you to identify what type you are dealing with and how you'll be able to deal with them, so that you will not find yourself in a difficult situation. My name is Mr. Samson Anane. This program is brought to you by Abundant Grace TV, and it is kindly supported by Charismatic Praise Ministry International in Obuasi. Don't forget, we are in COVID-19 period. Try to practice social distancing. Wash your hands as frequently as possible. If you want to use sanitizers, make sure it is alcohol-based. Stay in the house if you don't have anything to do outside. This one too shall pass. May God bless us all. Make a date with me on Friday, and your academic road will be cleared. May God bless you.
Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.